and then whenever is appropriate, you may use them to lessen your calculations. So let's see. First of all, in order to prove any one of these, again, in the honors section, you would need to know the Riemann sums and all that stuff. I'm just going to write, again, Riemann sum so we can appreciate our shortcuts. So limit n goes to infinity, summation 1 to n of f of xn delta x. And there's the multiplication in between f of x and delta x. So that's called the Riemann integral, and we know now that it can compute area under the curve if everything is above x-axis, and it's going to compute the net if it's going above and below, so you have to split it up and so on. Now that splitting up was not defined earlier. So properties of definite integrals we start first by claiming that if you go from A to A, you just get 0 immediately. That should be common sense, because if you have some kind of function and you just go from A to itself A, there is no width. Since width is 0, 0 area. So that's property number 1. Property number 2. A to B f of x dx is equal to negative integral b to a f of x dx. Now this one is not that intuitive looking at the graph, but if you look at what the resulting stuff over here is, observe that you have f of b minus f of a, and on this side you would have f of a minus f of b, but luckily you have that minus in front to fix the signs so that you can have them equal. That's a little proof for it, which is awesome. And number 3 is the one that we were hunting for in order for us to do the area under the curve, and that is the one that you can split your integral into as many integrals you want, as long as you are picking the values between a and b in order. So a to b of some function f of x dx is going to be, let's say, a to c f of x dx plus integral c to b f of x dx. So technically, and then I have to mention that this c is between a and b. Now another graph works here. So if I'm computing area from A to B, I might find C and then compute integral A to C and then C to B. That's exactly what we did for the sine. When the sine over there went from 0 to 2 pi, and what I did is I cut it at pi, which is halfway into it. You don't have to do halfway, but I did by easier calculations. And then because I broke it in halves, you add area from the first integral to area to the second integral, because as you can see, they still create and fill the entire space that you were supposed to find the area for. So you are allowed to pick any value between A and B. Now, those of you going into Calc 2, gotta know that, because eventually you're going to run into something that is called improper integral in Chapter 7. That means that you actually might have a vertical asymptote. And the question is, can you integrate through the asymptote, around the asymptote, how does it work? And then stay tuned for Calc 2. If you're not planning on taking it, this is the good time to reconsider, because this is something very interesting. Well, all right, more properties now. These are called integrals of even and odd functions. Now, this is, again, for those students who really, really want to learn absolutely fastest way to solve integrals and do these things. NJT actually, I don't know if they still do it, but they used to support this awesome competition called Integral V, where all of the students would participate in the competition, and the one who solves the largest amount of integrals in the smallest amount of time, right? So whoever is the fastest wins some kind of prize. I'm sorry? That's for students. No. Well, yeah, in the graduate school, but that's for undergraduate students. I did participate actually once. I was holding the screen for the projector. Because yeah.
I don't know if that's a W. Definitely not a loss.
Yeah. I was just holding the screen down. I was literally sitting in front of the screen holding it like this. And there is a picture somewhere of me sitting like that, because we started the thing, and that thing for the projector, you can see it in the corner right there. The screen, the spring or something went haboom inside, like mid-competition, and just it wouldn't stay down. And they had blackboards, not these whiteboards for chisels, but the blackboards for chalk. You can't project on those with the projector. And they had to project integrals in order for that to be right. You can't write them, because as you are writing them, you're taking time, and these students would be solving them in their heads without writing anything down, and then it wouldn't be fair. Because, right, someone would not be able to see, and others would be able to see. So then I sat below, and I held the screen for about 45 minutes. It was a good exercise. That's why I'm so strong. I think they do, except they fixed the screens. They should. I hope they do.
I would hope in the past, like, however many years they got around to that.
Yeah. Or you'd be surprised how long it takes to fix something in education. Integrals of even and odd functions. This is where you get to exploit the symmetry. And again, only if you understand, if all of the mathematics works and flip, kind of gets together, it makes sense. So integral from negative a to a of f of x dx is equal to 2 integral 0 to a of f of x dx, and this is true only if this function is even. And I will demonstrate both of these. Second one states negative a to a of f of x dx. If the function is odd, you get 0. We already have confirmation for number 2. That's the integral of sine x. Sine is the odd function. You were asked to memorize that in your pre-calc 2 course. And explanation for that will be in calc 2. Why is the sine odd? Why is cosine even? All you need to do is to wait for the chapter on power series, chapter 9. In calc 2 answers those questions and many, many more. So we already did the example for number 2. It was sine, and you saw that it worked out to be 0. That was previous lecture. The one on top says that if you have even function, which means symmetric on the y-axis, if you have even function then you can compute half of it and double it. So cosine is such a function, and you can. So example for this, I'll just say example done in 5.3 integral sine x, blah, blah, blah. Well, actually, wait. But yeah, that one's symmetric on pi. Yeah, I'll do another example. Doesn't matter. I'll do another example. Now let's go with this one first. So integral, let's say negative pi over 2 to positive pi over 2 for cosine of x dx. So you see the symmetric interval, and if you are to draw this, it's just going to look like this because it stops at pi over 2. Cosine would like to continue both ways, but we cut it at negative pi over 2 and pi over 2, so it doesn't do anything anymore. That's it. So now if you compute this, the integral of cosine is sine x computed from negative pi over 2 to positive pi over 2, which is sine pi over 2, which is 1, minus negative sine, sine of negative pi over 2. No plus c, because definite integrals will give you a number at the end. Only indefinite integrals have plus c. But if you have limits, the numbers, then you will be computing a number at the end. So no plus c. Sine of pi over 2 is 1. And now minus sine of pi over 2, because sine is the odd function, and the property of odd functions is that this minus can float all the way out in front. 1 plus 1 equals to 2. So we just computed power through figuring out the integral. But what we could have done is to double 0 to pi over 2 cosine x dx, which will reduce some of the calculations. We don't necessarily gain a step, but it definitely gives us faster answer. So this is going to be 2. Integral of cosine is sine x computed from 0 to pi over 2, which is 2 times 1, and I'll write it out, equals to 2 times sine of pi over 2 minus sine of 0. Sine of pi over 2 is 1, sine of 0 is 0, so 2 times 1 is 2. And that takes care of the problem. So as you can see, whether you do it the standard way or you use the formula, you still have to get the same answer. Ready for more? Of course, that's the spirit. So what is the integral from negative 1 to 1 of 2x squared 2x squared dx? So use the property. Try to use the property. What's the answer? 4/3.
So for this, when you half it and double it, that's what we're doing, right?
Yeah. So I'm going to double integral 0 to 1 of 2x squared dx, which is ultimately 4 integral 0 to 1 x squared dx, because the function is even. F of x is even. It's x squared. So now it's 4 x to the 3 over 3 computed from 0 to 1, and my comment you were right. 4/3.
So, but the midpoint, is that always going to be 0, or wherever the middle of the...
Yes.
Yeah.
Look.
That's kind of like...
Look at definition. A, negative A. It requires it to be the same number with the opposite sign. That's encoded, which automatically means that 0 must be in the middle every time.
Oh, but that was for the odd one, but the even one has 0 on the bottom.
It doesn't matter,
Okay.
because it's from negative A to positive A. So from negative 3 to positive 3, from negative 100 to positive 100. 0 is always dead center there. Just because we use A and A. Negative A and A. Cool.
When you get from 2 and then 2x squared, how did you get that to 4? Right, so you just...
2 times 2 is?
Yeah, 4.
4. And the constants can float in front of the integral, right?
That's what, so like the x squared can just stay, and then that's what...
X squared must stay, because we are yet to multiply by dx. Cool. The last concept in 5.4 is how to compute averages, average of a function. So there's a formula for that. F average, which is the bar on top, is equal to 1 over b minus a integral a to b of f of x dx. That's it. Notation for average is this f with the bar. And the reason why you want this and how to know is because velocities and acceleration, all of those are integrals and derivatives of each other. And then you also have markets, you also write with money, business, and so on. There is also, I mean, they are very interested in figuring out the averages and so on. Let's take a look at the problem from the homework. Again, we're not learning new types of integration, so whatever this function is to over here, you get to use whatever from that list that we talked about. Just hope it's not secant q. That's insane to solve. So let's take a look at the homework problem. Oh, found the perfect one for you, since the performance was stellar on the exam on this particular. Do we all know what's coming up? Yeah. Find f prime for f of x equals 1 over x on 1 to e. Go. Not sleeping. What do you get?
1 over e minus 1.
Let's take a look. So f average is going to be 1 over b minus a, so e minus 1, integral 1 to e 1 over x dx, which is 1 over e minus 1 times ln absolute x computed from 1 to e. Again, no plus c because we have a definite integral. We have limits. 1 over e minus 1 is going to be ln of e minus ln of 1. Well, ln of 1 is 0, and this guy is 1, so the answer is 1 over e minus 1. That's the average. What does that mean? So 1 over x looks like this. Let's say this is number 1, this is number e. The average, let's say it's there. About a little bit lower. So you need to know the average formula for sure for the final. These symmetry formulas, you are learning them if you want to know shortcuts. You can always do the integral regular way. Just make sure you don't miss any of the negative parts. And going back to the first 3 properties of definite integrals, if it goes from a to a, it's 0. If it goes from a to b, you can switch it. And we might run into some problems where we need actually this switching, because you do use substitution changes limits. And if you change limits, you might end up with a bigger number in the lower limit. And in that case, you would have to use this theorem to flip it. And we already used number 3. So I'm going to, again, stop the stream. And in about 10 minutes,